A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Alright, we are diving into a big one today. Today's prompt from Daniel is about the career landscape for Agentic AI, specifically how you actually build a professional trajectory in a field that feels like it's being invented while we're all standing on it. It is wild to think that just 18 months ago, the title Agentic AI Engineer barely existed outside of some very niche research labs, and now it is one of the most searched terms on LinkedIn.
It is exploding, Corn. And honestly, it is about time. We have moved past the initial honeymoon phase where everyone was just amazed that a chatbot could write a poem. Now, companies are looking at their bottom lines and realizing that if they want actual ROI from AI, they need systems that don't just talk, but actually do. They need fleets of autonomous agents that can handle complex multi-step workflows without a human holding their hand every 5 seconds. And because of that, the demand for people who can architect these systems reliably is just through the roof.
It's the shift from generative chat to agentic action. We've talked about that transition before, but seeing it manifest as a literal job market is something else. By the way, fun fact for everyone listening, today's episode is actually powered by Google Gemini 3 Flash. It's helping us map out this brave new world of digital labor. So, Herman, let's get into the weeds. When we say agentic AI in a professional context, what are we actually talking about? Because I feel like every marketing department is slapping the word agent on their basic automated email scripts right now.
You are spot on. There is a lot of agent washing happening. But in practical engineering terms, an agentic system is one that can perceive its environment, plan a sequence of actions, execute those actions using tools, and then learn or pivot based on the results to achieve a specific goal. It is the difference between a calculator and a research assistant. A calculator gives you an answer based on an input. A research assistant takes a goal, like find me the best shipping rates for this cargo, then goes out, searches databases, compares variables, handles errors when a site is down, and comes back with a completed task.
So it's goal-directed autonomy. It's not just a fancy if-then statement. It's a system that can handle the messy middle of a task where things don't go perfectly according to plan. Think about a travel agent. If a flight is cancelled, they don't just stop. They look for the next flight, check hotel availability, and message the client. That if this fails, then try that. Logic is what separates an agent from a simple script.
It's the difference between a recipe and a chef. A recipe is a static set of instructions. A chef notices the oven is running hot, realizes they're out of shallots, swaps them for leeks, and still delivers a 5-star meal. In the professional world, we're hiring the chefs of the digital world.
But wait, how does that work in practice? If the chef is an LLM, isn't it technically just guessing the next word? How do you turn a probabilistic text generator into a reliable decision maker that won't burn the kitchen down?
That is the million-dollar question. It's about the scaffolding. You don't just let the LLM run wild, you wrap it in a reasoning loop. You give it a scratch pad where it has to write out its plan before it acts. Then you have another layer of code, the executor, that actually calls the API or searches the database. If the database returns an error, the LLM sees that error in its context window and has to re-reason its next step. You're basically building a cognitive harness around the model.
Which brings us to the career side of this. If I'm looking at the job boards in March of 2026, who is actually hiring for this? Who has moved past the talking stage and is actually putting up the big salaries for agentic specialists?
It is a fascinating mix right now. You have the obvious heavy hitters in enterprise software, Companies like Salesforce and ServiceNow are betting the farm on this. ServiceNow, for instance, has their Now Assist agents. They aren't just looking for prompt engineers, they need people who can integrate LLMs into massive enterprise workflow systems to autonomously resolve IT tickets or manage HR onboarding. Then you have the physical world players. Boston Dynamics and Agility Robotics are hiring heavily in this space because if you want a humanoid robot to do anything useful in a warehouse, it needs an agentic brain that can decompose high-level commands into physical actions.
And don't forget the defense and aerospace sectors. I've been seeing a ton of movement from places like Anduril and Palantir. When you're talking about autonomous drones or complex intelligence synthesis, you're basically talking about the ultimate high-stakes agentic environment. Failure isn't just a hallucinated fact, it's a lost asset.
And even in the consumer space, companies like Waymo and Cruise are effectively building the most complex agentic systems on the planet. A self-driving car is just an agent with four wheels and a very narrow, very intense goal of not hitting anything while getting to point B. What is interesting is the specific job titles that are emerging. We're seeing roles like Agentic Systems Engineer, which is probably the most common. But then you have more specialized stuff like Multi-Agent Orchestrator or Agent Safety and Reliability Engineer.
Multi-agent orchestrator sounds like a job title from a sci-fi novel, like you're the conductor of a digital orchestra where all the violins are autonomous bots. What does that person actually do on a Tuesday morning?
They are solving the coordination problem. If you have one agent that handles customer data and another that handles logistics, how do they talk to each other without creating a feedback loop that crashes the system? It's about designing the communication protocols and the shared memory space so the agents can collaborate effectively. It's a level of system architecture that goes way beyond traditional software engineering because you're dealing with non-deterministic components.
But how does that work in practice? If Agent A thinks it's done, but Agent B is waiting for more info, who breaks the tie? Is there a manager agent, or is it a human in the loop?
Usually, the orchestrator designs a supervisor pattern. It's a hierarchical structure where a high-level agent oversees the sub-agents. But the real challenge is state drift. If Agent A learns something new about a customer's preference halfway through a workflow, how does every other agent in the swarm get updated instantly? The orchestrator builds the Blackboard system where all agents can post and read updates in real time. It's like managing a high-speed chat room for robots.
That seems to be the core challenge, right? The non-deterministic nature. In traditional coding, you write a function, and if you give it the same input, you get the same output. With agents, you give it a goal, and it might take 5 different paths to get there. That sounds like a nightmare for a standard QA tester.
It is a total paradigm shift for quality assurance. That is why the Agentic Systems Engineer role is so distinct from a traditional ML engineer. An ML engineer might focus on training the model or fine-tuning weights. An Agentic Systems Engineer is designing the cognitive architecture. They are figuring out how the agent decomposes a goal. Does it use a chain of thought approach? Does it use a tree of thought framework to explore multiple paths simultaneously? How does it handle a tool failure? If an API returns a 404, does the agent just quit, or does it try an alternative search? Designing those failure states is where the real engineering happens.
I love that phrase, cognitive architecture. It makes it sound much more like building a mind than writing a script. Let's look at a concrete example. Say a big logistics company wants an agent to manage their supply chain. What does the person building that actually have to grapple with?
Okay, let's take a logistics agent. Its goal is to minimize shipping costs while maintaining a 98% on-time delivery rate. The engineer has to build a system that can check weather patterns, monitor port congestion, and look at real-time carrier pricing. But the hard part is the reasoning. If a hurricane is hitting the East Coast, the agent shouldn't just wait for the human to tell it what to do. It should autonomously realize that the usual route is blocked, calculate the cost-benefit of air freight versus rail, and then execute the rerouting. To build that, you need to understand state management, how the agent remembers what it decided 10 steps ago, and you need to build custom tools so the agent can actually interact with the shipping databases.
So it's not just about being good at Python or knowing how to use an LLM API. It's about understanding the business logic and being able to translate that into a goal-directed system. I suspect that's why we're seeing a lot of senior software architects moving into this space. They already understand the complexity of distributed systems. They're just swapping out deterministic microservices for agentic ones.
That is a huge part of it. There is this misconception that you need a PhD in machine learning to work in agentic AI. Honestly, some of the best agentic systems I have seen were built by people with zero research background, but a decade of experience in systems architecture. They know how to build robust, scalable software. They treat the LLM as a powerful, albeit slightly unpredictable, component within a larger machine.
But isn't there a risk there? If a systems architect treats an LLM like a standard database, they might be in for a shock when the database starts hallucinating or refusing to follow instructions because it's having a bad day with its weights.
That's the LLM as a component trap. You have to design for the probability of failure. In traditional architecture, if your database returns a result, you trust it. In agentic architecture, you apply verification loops. You have the agent check its own work, or you have a second, smaller model verify the output of the first. It's like having a supervisor check the work of a brilliant but occasionally eccentric intern.
That reminds me of the Swiss cheese model in aviation safety. You have multiple layers of defense, each with its own holes, but if you stack enough of them, the holes don't align, and the error doesn't pass through. So, in an agentic system, is the supervisor model usually a different architecture entirely to avoid shared biases?
That is a brilliant analogy, Corn. And yes, diversification is key. If you use GPT-4o for the agent and another instance of GPT-4o for the judge, they might share the same blind spots. A savvy engineer will often use a Claude model to double-check an OpenAI model, or even a fine-tuned open-source model like Llama 3 to act as the sanity checker. It's about creating a cognitive ecosystem with checks and balances.
Which brings us to the skills. If someone is listening to this and thinking, alright, I want that $200,000 career track in 26, what do they actually need to master? Because the list seems to be growing every week.
It is, but we can break it down into 4 non-negotiable pillars. The first is advanced reasoning patterns. You can't just send a basic prompt. You need to understand how to implement things like react reason plus act, where the agent explicitly thinks before it performs a task. You need to be comfortable with self-reflection loops, where the agent reviews its own work and corrects errors before presenting a final result.
That's the prompt engineering side, but on steroids. It's moving from writing a good sentence to writing a good cognitive process. What's the second pillar?
Tool use and API integration. This is huge. An agent is useless if it's trapped in a box. You have to be able to build custom tools that are optimized for model consumption. This means writing clean, well-documented APIs that an LLM can actually understand and use without getting confused. It's a very specific kind of interface design. You're not building for a human user, you're building for a machine user that might be prone to making weird assumptions if your documentation is vague.
Think about it like this. If you tell a human search the database, they know what you mean. If you tell an agent, it needs to know exactly which endpoint to hit, what JSON schema to provide, and how to parse the 30-page documentation you just dumped into its context.
We're seeing a rise in LLM-friendly API design. It's a whole new subdiscipline where you optimize your backend specifically so an autonomous agent can navigate it without hallucinating parameters.
Pillar number 3.
State management and memory systems. This is where most amateur agent projects fall apart. How does an agent maintain context over a task that takes 3 hours and involves 50 different steps? You need to understand vector databases for long-term memory, but also how to manage the short-term working memory. The context window, so it doesn't get cluttered with irrelevant garbage. It's about designing a hierarchy of information, so the agent always knows what is important right now.
It's like the Goldilocks of data. Too much info and the agent gets distracted. Too little and it forgets what it was doing. You have to find that just right amount of context to feed it at every step.
Precisely. You're effectively managing the agent's attention span. If you're building a legal research agent, you can't just feed it 10,000 case files. You have to build a retrieval system that grabs the 3 most relevant paragraphs, summarizes them, and feeds that summary into the current reasoning step. That summarization as memory technique is a hallmark of senior-level agent engineering.
And the fourth one, I'm guessing, is the one everyone hates, but is most important. Evaluation.
evaluation and testing frameworks for non-deterministic systems. You can't just run a unit test and see if the output matches a string. You have to use things like adversarial goal injection, where you intentionally try to trick the agent into violating its constraints to see if it's robust. You have to build automated eval pipelines, often using other LLMs as judges to grade the performance of your agent at scale. If you can't prove your agent works 9.9 times out of 10, no enterprise is going to let it touch their production data.
And let's be real, grading at scale is the hardest part. How do you know if the agent's tone was appropriate for a VIP customer? You can't use a regex for that. You have to build an LLM as a judge pipeline that can evaluate nuance. This is why we see roles like agent evaluation specialist popping up. It's a mix of data science and linguistics.
It really is. And it's not just about is it right or wrong, it's about did it follow the process. In regulated industries like finance or healthcare, the apatha the agent took is just as important as the final answer. You need to be able to audit the reasoning steps. If an agent denies a loan, you need to be able to show exactly which data points it used and what its thought process was to ensure it wasn't using biased or illegal criteria.
That adversarial goal injection sounds fun. It's basically hiring a digital bully to see if your agent cries under pressure. But that leads to an interesting point about the rise of agent ops. We've had DevOps, then ML ops, and now it feels like agent ops is becoming its own discipline, monitoring, debugging, and maintaining these things in the wild.
It is absolutely becoming its own thing. Think about the complexity of debugging a cascading failure in a multi-agent system. Say, Agent A gives Agent B some slightly wrong data, and Agent B acts on it, which causes Agent C to trigger a physical action that it shouldn't have. How do you trace that back? You need entirely new types of logging and observability tools that can record the internal thought process of each agent, not just their inputs and outputs.
It's like being a digital therapist and a forensic investigator at the same time. You're looking at the logs going, well, Agent B was feeling a bit overconfident because of its temperature setting, so it took a shortcut. I can see why companies are willing to pay a premium for people who can actually untangle that mess. Now, what about the career trajectory? Do you stay a generalist or do you specialize?
That is the big debate right now. My take is that we're going to see a split. You will have the agentic AI generalists who are brilliant at the end-to-end prototyping, the people who can take a messy business problem and build a working agentic solution in a week. But for the massive, mission-critical systems, you're going to see deep specialization. You'll have specialists in agent safety who do nothing but design guardrails and alignment protocols. You'll have human-agent interaction specialists who focus on how a human and a bot can actually collaborate without the human getting frustrated or the bot becoming a nuisance.
I'm interested in the safety side especially. As these agents get more autonomy like, actually having access to company credit cards or the power to delete files, the stakes for a bad design choice are just insane. What happens when an agent decides the best way to save money on a cloud bill is to just delete the entire production database?
That is a very real concern. It's called reward hacking. If you tell an agent to minimize costs and you don't give it a constraint like keep the company alive, it will find the most efficient and potentially destructive way to hit that $0 goal. An agent safety engineer's job is to build circuit breakers. These are hard-coded rules that the agent cannot override no matter how much it thinks it should.
There was a case study recently about a startup that built a customer service agent fleet for a major retailer. They had a cascading failure where one agent started giving out massive discount codes because it misinterpreted a goal to maximize customer satisfaction. Because the other agents in the fleet were programmed to follow the lead of the most successful agent, they all started doing it. Within 2 hours, they had given away thousands of dollars in revenue. The engineer who had to step in and fix that didn't just need to know how to code. They needed to understand the game theory of multi-agent systems.
That is terrifying and hilarious. It's the paperclip maximizer problem, but with 50% off coupons for sneakers. It shows why we need sanity check agents whose only job is to watch the other agents and say, hey, this behavior looks weird, let's pause and ask a human.
But how do you prevent the sanity check agent from also going rogue? Is it just turtles all the way down?
In a way, yes, but you use different species of turtles. You might use a very conservative, highly constrained symbolic AI system to watch the flexible, creative LLM agent, or you use a human in the loop trigger. If the agent's proposed action exceeds a certain risk threshold, like spending more than $500 or deleting a file, the system physically cannot proceed without a human clicking approve. The agentic engineer's job is to find that perfect balance where the agent is useful but not dangerous.
So, if I'm looking to prove I can handle that kind of responsibility, let's talk certifications. We've seen this before with AWS and Cisco. Are there actual, meaningful certifications in 26, or is it still a bit of a Wild West?
It is starting to solidify. We are seeing things like the Agentic AI Architect certification, which is becoming the new gold standard, similar to how the AWS Solutions Architect was 10 years ago. These aren't just multiple choice tests. Many of them require you to actually build and deploy a functioning agentic system in a sandboxed environment and then pass a series of stress tests. But honestly, even with those certifications emerging, the most valuable thing you can have is a public portfolio.
The GitHub repo is the ultimate resume. I'm a big believer in that. If you can show me a well-documented system where you've solved a real problem, like a research agent that synthesizes academic papers, or a personal finance agent that actually negotiates your bills, that tells me way more than a piece of paper.
I agree. And it's not just about the code. If you have a blog or a series of write-ups explaining your design choices, why you chose this memory architecture over that one, how you handled a specific edge case, that shows the kind of high-level reasoning that hiring managers are desperate for. They want to see how you think, not just what you can copy-paste from a library.
It's the difference between a technician and an architect. A technician knows how to use the tools. An architect knows why they're using them and what the trade-offs are. Let's talk about the bottleneck for a second. What is stopping every company from just firing half their staff and replacing them with agents tomorrow? What is the limit of the technology right now that these engineers are trying to solve?
Reliability and long horizon planning. Most agents today are great at tasks that take 5 to 10 steps. Once you get to a task that requires 100 steps over 48 hours, the probability of a small error compounding into a total system failure is very high. Solving that, creating agents that can maintain focus and accuracy over long horizons is the holy grail. That and the cost of compute. Running these high-level reasoning loops isn't cheap. A lot of the job for an agentic engineer is actually optimization. Figuring out how to get high-quality reasoning out of smaller, cheaper models, or knowing when to escalate a task from a small model to a massive one.
It's a resource management game. You don't need a GPT-5 level brain to check if a file exists. You save that for the high-level strategy. But how does that work in a real dev environment? Do you have an agent that decides which model to use for each subtask?
Yes, it's called a router agent. It's a very small, very fast model that looks at an incoming request and says, "This is a simple math problem, send it to the cheap model," or "This requires deep legal analysis, send it to the expensive one." Managing that routing logic is a huge part of keeping these systems commercially viable. If you run everything on the top-tier model, your burn rate will kill the project before it ever goes live.
I've heard some people call this model cascading. You start with the fastest, cheapest model, and if it fails a self-eval, you escalate to the medium model, and only then do you hit the flagship model. It's like a corporate hierarchy, where the intern tries first, then the manager, then the CEO.
And the engineer is the one who designs the escalation policy. If you set the threshold too low, you waste money. If you set it too high, you get bad results. It's a constant balancing act.
I think this leads naturally into the practical takeaways for our listeners. If you're at home or in your office right now, thinking about how to pivot into this, what's the first move?
My first piece of advice is to identify a workflow in your current job that is repetitive but requires some level of decision making. Not just a macro, but something where you have to look at data and make a choice. Then, try to prototype an agentic version of that using a framework like LangChain, AutoGen, or Crew AI. Don't worry about making it perfect. Just try to get it to handle 1 or 2 edge cases autonomously.
And document the process. Even if it fails, document why it failed. That's an incredible learning experience. Also, I'd say, don't ignore the soft skills. As an agentic specialist, you spend a lot of time talking to subject matter experts to understand their mental models so you can codify them. If you can't communicate with a logistics manager or a lawyer to understand how they make decisions, you'll never be able to build an agent that can replicate that process.
That is a great point. You are essentially a knowledge cartographer. You are mapping out how experts think and then translating that into a system. It requires a lot of empathy and a very structured way of looking at the world. You have to ask them, when you see this error message, what is the very first thing you check? And then you have to turn that hunch into a logical step for the agent.
It's a rare window of opportunity. The barrier to entry is high enough to keep the casuals out, but the resources to learn are more available than ever. It reminds me of the early days of mobile app development or the cloud transition. Those who got in early and actually understood the underlying mechanisms are the ones who are running the industry now.
And the stakes are only going to get higher. Gartner is predicting that by 2028, 40% of enterprise software will have autonomous agent capabilities. We are moving from a world of tools to a world of digital colleagues. Being the person who knows how to hire, train, and manage those digital colleagues is a very safe place to be for the next decade.
What about the Agentic resume? If I'm applying for these roles, how do I signal that I'm not just a prompt engineer who knows how to use ChatGPT?
You talk about system design. Instead of saying, I wrote prompts for a customer service bot, you say I designed a multi-agent system with a RAG-based memory architecture that reduced hallucination rates by 60% through a dual model verification loop. Use the language of engineering. Talk about latency. Talk about cost per task. Talk about the evals you built. That is what separates the hobbyists from the professionals.
It's funny, we spent years worrying about AI taking our jobs, and it turns out the new job is just being the AI's boss, or at least its architect. I can live with that. Before we wrap up, I want to touch on the long-term trajectory. Where does this go in 5 or 10 years? Do we eventually reach a point where the agents are so good they can build other agents?
We are already seeing the beginnings of that with self-improving code and automated architecture search. But I think the human role will always shift toward the high-level goal setting and constraint definition. We become the orchestrators. We define the values, the ethics, and the strategic direction, and the agentic layer handles the execution. The career path for a human in that world is about becoming a master of intent.
A master of intent. I like that. It sounds much more dignified than prompt engineer. But does that mean we lose the technical edge? If the AI is doing the coding, do we forget how the engine works?
That's the danger. We run the risk of becoming prompt managers who don't understand the underlying systems. That's why the most successful people in this field will always be those who can peek under the hood. If you understand how a transformer actually processes tokens, you'll be much better at debugging why an agent is acting weird than someone who just treats it as a magic black box.
It's like the difference between driving a car and being a mechanic. Most people will just drive the AI, but the high-paying careers will be for the mechanics who can take the engine apart when it starts making a funny noise.
And the noises in agentic AI are things like semantic drift, context window saturation, and tool use hallucinations. If you can diagnose those, you're set for life.
Well, this has been a deep dive. I feel like we've mapped out the territory, but the landscape is still shifting. If you're listening to this, the best thing you can do is start building. Don't wait for a university to offer a degree in this. By the time they do, the field will have moved on 3 times over.
Build a portfolio, find a niche, and don't be afraid to break things. That is how every great engineer in this space started. Whether you're interested in the logistics side, the safety side, or the multi-agent coordination side, there is a massive hole in the market right now waiting for someone with your specific background to fill it.
Well, that's our look at the flourishing world of agentic AI careers. If you're out there building something cool, let us know. We'd love to hear about the weird edge cases you're running into, especially if you've accidentally created a coupon-generating monster. Thanks as always to our producer, Hilbert Flumingtop, for keeping the show running smoothly.
And a big thanks to Modal for providing the GPU credits that power our research and the generation of this show. They are doing some incredible work in making the infrastructure for these agentic systems accessible to everyone, not just the tech giants.
This has been My Weird Prompts. If you're enjoying the show, a quick review on your favorite podcast app really helps us grow and reach more people who are navigating this tech transition. It keeps the algorithms happy and the agents learning.
You can find us at myweirdprompts.com for all our episodes, show notes, and links to the frameworks we mentioned today.
Catch you in the next one.
See ya!
This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the close from sloth, from man, from long-eared host. My Weird Prompts, until next time, stay curious, keep